When riding in an elevator, have you ever wondered why sometimes you feel really heavy and sometimes you feel really light? Let's take a look and see exactly why that happens according to the forces and how they're acting on you. Let's first just take a look at a regular example and let's see how a scale works. Let's say you're 55 kilograms and you decide to weigh yourself. What is our weight in newtons? Well, here's your scale. You're standing on it. And you have two forces acting on you. You have the force of gravity going down, and you are going to have the force of the normal from the scale pushing back up. To figure out your force of gravity, you'd simply take your mass and multiply by 9.8 meters per second squared. So that would equal 55 kilograms times 9.8, which equals 539 newtons. Now, since you're not accelerating at that point in time, your normal, which is what the scale is going to read, would equal the 539 newtons. Now, let's talk about what happens when you're in an elevator. Let's say that you are that same 55 kilogram person, but this time you are inside of an elevator. The scale and gravity are still the only two things that are acting on you. You have force of gravity pulling down, and you have the force of the normal going up. However, in this situation, you are accelerating downwards. You have an overall acceleration of 3 meters per second squared. How this affects the problem is that now our net force does not equal 0. So let's take a look at this. Just like in the last problem, we want to figure out which way is positive and which way is negative. Keeping with that same convention, since we're accelerating downward, I'm going to say that down is positive and up is negative. That may seem a little strange right now, but it'll make problems in the future easier. So if I set up my net equation, I'd say that force net is going to equal my force of gravity. I'm calling that positive because that's helping me go downward, and that's the direction I'm headed, minus my normal force from the scale. That's hindering my progress, so it's negative. Then I would say force net is the same thing as mass times net acceleration equals my force of gravity. We're the same person. We have the same gravitational field, so that's still going to be the 539 newtons minus my normal force, right? I'm going to move some stuff over to make it make more sense. Okay, I'm going to add force normal over here. Force normal would equal then 539 newtons minus mass times net acceleration. Okay, all I did was I added force normal to both sides, and I subtracted mass times acceleration from both sides. Okay, therefore my normal force is going to equal 539 newtons minus 55 kilograms times my overall net acceleration of 3 meters per second squared. My normal force now is going to be 539 minus 165 newtons, or only 374 newtons. You feel a lot lighter when you're going down in an elevator because you are removing some of that normal force. The floor is no longer pushing up quite as much on you because you are accelerating downward. It's kind of a fun little experiment. In the reverse, if we were accelerating upwards, you would feel heavier. And that's why sometimes you feel like you're compressed, because that normal force from the floor is pushing so much more up on you. You will be doing a practice problem with this in the near future. All right, one more practice for tonight, and then we'll go from there.